In this video, we are looking at a theory that helps us determine the shape and geometry of molecules. This theory is called valence electron pair repulsion theory. So really, this theory uses the fact that electrons will repel each other, because we know that like charges repel each other. So what does this theory say? So valence shell electron pair repulsion theory says that bonding and non-bonding electrons, bonding and non-bonding electron groups around a central atom assume geometry that put them further apart from each other to minimize electron repulsion. So, for example, if you have an atom, what we call a central atom, C, this atom will have electron groups surrounding it. So electron groups means pairs of electrons. So for carbon, we may have one electron group here, another electron group here, a third electron group here, a fourth electron group here. All these groups forming a chemical bond. So here we can say that this carbon has 4 electron groups surrounding it. So the carbon we have there has 4 electron groups surrounding it. So this is group 1, this is group 2, this is group 3, this is group 4. So we are saying in this case, each pair is a group of electrons. Or we can talk about nitrogen. So nitrogen also has 4 electron groups surrounding it. Each chemical bond here is an electron group. So each chemical bond in nitrogen is an electron group. Now, this group here is known as non-bonding group. So each chemical bond in nitrogen is an electron group, but there is also a non-bonding electron group. So this nitrogen has 4 electron groups. This is 1, this is 2, this is 3, and this is 4. So the geometry of nitrogen will depend on the fact that nitrogen is surrounded by 4 electron groups. Now, what does this theory tell us? So the VSEPRa theory tells us two things about a molecule. So the first thing that VSEPRa theory tells us, it is going to tell us about the geometry of the molecule. So it gives us information about the geometry of the molecule. The second thing this theory will tell us is that it gives us information about the shape of the molecule. So we are going to see how different these two terms are: geometry of the molecule and shape of the molecule. So what is the difference between a molecular geometry and molecular shape? Molecular geometry just deals with the groups of electrons around a central atom. So, for example, I talked about um, ammonia. So, ammonia is written as, we have one group here of electrons, then we have these chemical bonds. So, that is ammonia. So, the geometry of ammonia will say that the nitrogen is surrounded by four groups of electrons. That's what the geometry will say. The geometry will say in ammonia, the central nitrogen is surrounded by four groups of electrons. So this is group 1, group 2, group 3, group 4. These are four groups of electrons. In this case, each group is a pair of electrons. That's what the geometry will say. What about the shape? So if we look again at ammonia, shape will say that ammonia has three chemical bonds surrounding nitrogen. So really, shape focuses on how many chemical bonds are surrounding the central atom. In this case, our central atom is nitrogen, while geometry focuses on how many groups of electrons are surrounding the central atom. So that's the difference between molecular shape and molecular geometry. And we'll look at this difference in detail when we solve some problems. Let's look at some examples. So, what are molecular shapes from electron arrangements? Normally, if you want to determine the shape of a molecule or the geometry of a molecule, the first thing is to understand that you always have this central atom. So we have the central atom, and then we have peripheral, or I'll just say side atoms surrounding the central atom. So when you want to determine the geometry of the shape, we are looking at these two. We must have a central atom, and then we must have side atoms that surround this central atom. So let's look at the example that we have here. If we look at this molecule given here, this is beryllium dihydride. So BeH2, beryllium dihydride. But now the way beryllium dihydride is written, it is showing that we have a central atom, which is beryllium here, and two side atoms, which are hydrogens. Now, let's suppose you are given beryllium dihydride. So let's suppose you are given beryllium dihydride as indicated by the formula, as indicated by this formula. And let's suppose you don't know this information. You are not given this information. How do you determine the shape of this atom? How do you determine the shape? So to determine the shape of this atom, first you must determine molecular geometry first. So first, determine molecular geometry. So in terms of molecular geometry, we have, for this course, we are going to deal with three types of geometries. So three types of geometries, at least for this course. So the first one is known as linear geometry. So linear geometry occurs when you have a central atom surrounded by two groups of electrons. So in a linear geometry, central atom is surrounded by two groups of electrons, which means one group of electrons is here, the next group of electrons is here. So these two groups of electrons are surrounding the central atom. If you have that type of arrangement of electrons, you have a linear geometry. Then there is another geometry. There is another geometry. We call it a trigonal planar. So a trigonal planar is like a triangle. If you draw a triangle on paper in a plane, and within that triangle, you put a central atom here, and then you have side atoms. Yeah, my drawing is not looking. It's not looking good. So you have a central atom, and then you have side atoms. So like B, which is a central atom, then you have Cl here, another Cl here, another Cl here. So that is trigonal planar. So you have a plane like a triangle. In the middle of the triangle, you put your central atom, and on each corner of the triangle, you put your side atoms. So this one can be like a triangle. So you draw a triangle passing through here, here, and here. So this is called trigonal planar. So that is the second geometry. Now, when do you have a trigonal planar? You have this when the central atom is surrounded by three groups of electrons. So for example, if we take B, Cl, Cl, and Cl. So this is the first group of electrons. This is the second group of electrons. This is the third group of electrons. So if the central atom is surrounded by three groups of electrons, you have a trigonal planar. So take note of this. Now the third geometry we are going to discuss is called tetrahedral. So a tetrahedral is like a pyramid. So a four-sided pyramid. So there will be another side there. So a tetrahedron is a four-sided pyramid. So in this four-sided pyramid, you can have a central atom in the middle of the pyramid. And then you have side atoms. One atom will go here. Another atom will go there. A third atom will go there. One, two, three. One, two. Oh, let me just make some corrections here. So this tetrahedron is kind of a three-sided pyramid, not four-sided pyramid. So this is the first side of the pyramid. This is the second side of the pyramid. If I put this one there, behind there is the third side of the pyramid. Or actually, I'm just confusing something. All right, so just forget about it. Let me start all over on the tetrahedron. So a tetrahedron is a four-sided pyramid, not three-sided pyramid. So I'm gonna draw the pyramid again. So this is our pyramid. And then in here, in there. So we have this one, this is side one. Then we have this side, the other side there, side two. Then we have this side, side three. Then we have the side down there, side four. So it is a four-sided pyramid. So what do we do with this four-sided pyramid? So this is a tetrahedron. So this is a four-sided pyramid. We put the central atom inside the tetrahedron, at the center of the tetrahedron. And then from there, a chemical bond comes from this side to this end of the pyramid. Another chemical bond comes from this side to this end of the pyramid. A third chemical bond goes to this end of the pyramid, and a fourth chemical bond goes to this end of a pyramid. Which means if you have a molecule like methane, you have your carbon here in the middle, and then you have one hydrogen, which is this one. Then you have another hydrogen here, which is this one. Then you have another hydrogen here, which is this one. And then you have another hydrogen there. So you have a tetrahedral molecular geometry. So when do you have a tetrahedron? You have a tetrahedron when the central atom is surrounded by four groups of electrons. That is, when you have a tetrahedral. So in this case, central atom is surrounded by 4 groups of electrons. Now we have other shapes or other geometries that we are not going to talk about. Now, these are the geometries. We say we have 3 geometries that we are discussing in this class. That is linear geometry, trigonal planar geometry, and tetrahedral geometry. Now let's figure out from these geometries, how do we get shapes? So a linear geometry will give you a linear shape. So a molecule that has a linear geometry is also going to have a linear shape. So that is 1. Now we see the molecule that we have here, which is BeH. Each chemical bond is a pair of electrons. So normally when you have a linear geometry, according to the valence shell electron pair repulsion, our angle between the 2 chemical bonds is 180 degrees. So the question is, why am I adding Celsius? So the question is, why does a linear geometry have an angle of 180 degrees? The answer is because it's linear. Another question is, why do we have an angle of 180 degrees when the central atom is surrounded by 2 electrons? So why do we have a linear geometry when the central atom is surrounded by 2 groups of electrons? So that's a good question. Why do we have a linear geometry when the central atom is surrounded by 2 groups of electrons? The answer to this question is that the 2 electrons will have to stay as far, or the 2 groups of electrons will have to stay as far away from each other as possible. So the answer is the 2 groups of electrons will have to stay as far away from each other as possible to minimize repulsion we know that we are dealing with valence shell electron pair repulsion. So the best way, if you have two groups of electrons, if you have Be here and you have two groups of electrons, you don't want to put one here, another here, because they are too close here, they are going to repel each other. To avoid that, you need to put the two electrons as far away from each other as possible. So the best way you can do that is to put this group of electrons here and this group of electrons here to form these chemical bonds. As such, you are going to have a linear molecule with 180 degrees angle. So that's what we have here. This one is a linear molecule, and this is the angle that you get. Now, what about a trigonal planar geometry? A trigonal planar geometry will give you two shapes. It's going to give you two shapes. The first shape will also be called trigonal planar. So the first shape will be called trigonal planar. So this shape occurs when the central atom is bonded to three chemical bonds. So central atom bonded to three chemical bonds. So that's when you have a trigonal planar shape. But also you can have another shape. This shape is called bent. But remember, the geometry is trigonal planar. And trigonal planar is going to give us two shapes. The first shape will be trigonal planar. This is when the central atom is bonded to three chemical bonds, like what we see here. 1, 2, 3. So the geometry and the shape of this one will just be the same. The second shape is bent. So bent shape occurs when a trigonal planar geometry bonds to only two chemical bonds. So in this case, the central atom has two chemical bonds and one non-bonding electron pair. So it will be like, let's say the central atom is X, and you have a chemical bond here, another chemical bond here, and you have a lone pair here. So instead of having a third chemical bond here, you have a lone pair of electrons. So your atom, your molecule is going to have a bent shape. Bent means it's bent like this. So these are the two shapes that can come from a trigonal planar geometry. What about tetrahedral geometry? You can see the tetrahedral here, and methane as a tetrahedral, and this is a model of tetrahedral. So what about the tetrahedral geometry? Tetrahedral geometry is going to give you three shapes. So the first shape is tetrahedral. In this shape, the central atom is bonded to four so the central atom has formed four chemical bonds. So the central atom forms four chemical bonds. So that is tetrahedral. Like each central atom has a chemical bond, as you can see here. So the geometry will be tetrahedral and the shape will also be tetrahedral. There is another shape which we call trigonal. Let me just trigonal pyramidal. So in that shape, like in the case of ammonia, the central atom has three chemical bonds and one non-bonding pair. So example is ammonia. You can see it looks like a pyramid. So three chemical bonds here and one lone pair. That is trigonal pyramidal shape. But the geometry is still tetrahedral. Then we have a third shape. So we say we have three shapes here. Now, a third shape is known as bent. So three bent shape. So in this shape, the central atom forms two chemical bonds and has two non-bonding electron pairs. So an example is water. We have oxygen here, then the two chemical bonds, hydrogen, hydrogen. Then we have this pair here, and then another pair here. But we know that it has tetrahedral geometry because it has four groups of electrons surrounding the central atom. But because the central atom has only two chemical bonds, the shape itself is known as bent shape. So another thing that we can talk about on this is the bond angles. So in a linear geometry, the bond angle, that is this chemical bond, is 180 degrees. That's the bond angle in linear geometry. In trigonal planar, geometry, the bond angle is 120 degrees. This bond angle here is 120 degrees, 120 degrees, 120 degrees. In tetrahedral, the bond angle is 109.5 degrees. So here, 109.5, 109.5, 109.5, 109.5. So every bond angle in a tetrahedral is 109.5 degrees. So I already talked about the shape of molecules. Shapes of molecules in a tetrahedral. We said that tetrahedral has two shapes, which is trigonal, or three shapes, which is a tetrahedral itself, trigonal pyramidal, and bent. We did the same things. A trigonal planar has two shapes, which are trigonal planar and bent. So I want us to play around with some molecules and find out what their shapes are. So the first molecule is CH3, or the molecule itself can be given as C2H6. So how do we obtain the shape? So there are steps that you can do that. But what we have here are a little bit simpler molecules to come up with their shape. The first thing is to know which ones are your central atoms. Which ones are central atoms? Is it the hydrogen or is it the carbon? So normally one way you can recognize central atoms are smaller in number. Like for example, we have 6 hydrogens and only 2 carbons. So it tells us the carbons are central atoms. So we can put them, our central atoms together. This one is central atom. This one is another central atom. Now you just draw sticks to these central atoms and sticks to this other central atom. And then you can decide to say what is the geometry of each central atom. What is the geometry of each central atom? So that's a question you can ask. So I'm getting rid of these so that I have space to write on. So if you look at this molecule, if you take each stick is an electron pair. So each stick is an electron pair. So this central atom here, this central atom is surrounded by 1 pair, 2 pairs, the 3rd pair, the 4th pair. So central atom A, I'll call this central atom A, is surrounded by 4 groups of electrons. Central atom A surrounded by 4 groups of electrons. Therefore, its shape or therefore its geometry is tetrahedral. Shape is also tetrahedral. So why is the geometry and the shape equal? The issue is we say that a tetrahedral shape occurs when the central atom is surrounded by 4 chemical bonds and you don't have any non-bonding pairs. So in this case, we see that the central atom for the carbon here is surrounded by 4 chemical bonds. That makes the shape of carbon A tetrahedral shape. The same thing here, carbon B has tetrahedral shape. So carbon B is here. So what we are saying is the central atoms in this molecule, both of them are tetrahedral. So I just point them here. They are tetrahedral. So I can say that this one, molecular geometry, tetrahedral. Molecular shape, tetrahedral. Now let's look at this one. This one also has the central atoms, which are carbon, carbon, and then each central atom has two hydrogens. Each central atom has two hydrogens. But usually carbon must form four chemical bonds. Carbon must form four chemical bonds. So what we are going to do is just to add another chemical bond here, so that we have 1, 2, 3, and 4 chemical bonds for this carbon. And we have the same chemical bonds for this other carbon. So we need to take note of that. Carbon usually forms 4 chemical bonds. If you feel that the chemical bonds are not enough, you can have a double bond or a triple bond. Now, let's go to this carbon A. The question is, how many groups of electrons are surrounding carbon A? An important point. A double bond is taken as one group of electrons. So if you see a double bond, you take it as one group of electrons. So if we ask a question, how many groups of electrons are surrounding the central carbon A? So we have one group here, the group 1, group 2, and group 3, because we know that a double bond is taken as one group of electrons. So because of that, we can say that carbon A is surrounded by 3 groups of electrons. So carbon A is surrounded by 3 groups of electrons. So because of that, the geometry is trigonal. The geometry is trigonal planar. And because we don't have any non-bonding pairs, the shape is also trigonal planar. So whatever happens to carbon A is also happening to carbon B. So carbon B has the geometry trigonal planar and the shape also trigonal planar. So I'll get rid of this and go to the third one. So this one, we can say geometry trigonal planar, shape trigonal planar. So we'll do this third one and others in the next video. Thank you.